Imagine looking up at the night sky, not just with your eyes, but with most advanced instruments, sensitive enough to pick up whispers from the edge of the observable universe. Now, imagine those whispers are not gentle as they seem to be. Instead, they are colossal, blindingly powerful bursts of radio waves that last less than the blink of an eye. It is so powerful, in fact, that a single burst can be brighter than our sun by hundreds of millions of times. These are known as fast radio bursts, or FRBs, and for over a decade and a half, they have been one of the universe's most tantalizing, most interesting mysteries. They erupt from billions of light years away, and they leave scientists scrambling for answers. Are these signals the echoes of a cosmic catastrophe of unimaginable scale? Or could they be something else entirely? Something intelligent? In the few minutes of this video, we are going to embark on a journey into the heart of this cosmic mystery. We will explore the shocking discovery of FRBs, diverse into the wild theories, uncover the groundbreaking evidences, and reveal why these fleeting flashes might hold the keys to unlocking the universe's deepest secrets. Get ready, because the truth is out there, and it is stranger than fiction. Our story begins, as many great scientific discoveries do, quite by accident. It was in 2007 that Dr. Duncan Lorimer and his team were sifting through an archive data from the Parkes radio telescope in Australia, searching for something known as pulsars, a rapidly spinning neutron stars that emits regular radio pulses. It was painstaking work, and then they saw it. A single, incredibly powerful burst of radio waves. It was unlike anything they had seen before. It lasted only a few milliseconds, but its dispersion measure, that is how much the signal had been smeared out by passing through cosmic gas, indicated it had traveled billions of light years to reach us. This was not local interference. This was a signal from the truly deep cosmos. This was FRB 010724, now famously known as the Lorimer burst. For years, it was a one-off event. Then curiosity sets in. Was it a glitch? An unknown terrestrial event? Scientists needed more evidence. It was not until 2013 that more bursts were confirmed, finally establishing FRBs as a genuine astronomical phenomenon. As soon as the floodgates opened, specialized telescopes designed to probe the sky for these flashes started to revolutionize the field. So, what exactly makes an FRB an FRB? Let's break down their mind-boggling properties. 1. Extreme brightness. We're talking about energies equivalent to hundreds of millions of equivalent suns compressed into a fleeting moment. To put that in the right perspective, if an FRB were as close as the moon, it could potentially fry every electronic device on Earth. Luckily, they're billions of light years away from us. 2. Incredibly short duration. Just a few milliseconds. That is faster than a hummingbird's wing flap. This extreme brevity is indicative of something crucial. Whatever that is producing them must be incredibly compact, perhaps not larger than a few square miles. The vast distances, the vast majority of FRBs that were detected originates in galaxies far, far away. This isn't just a guess. Their high dispersion measure is the main giveaway. The more a radio signal interacts with electrons in space, the more it gets dispersed. A high dispersion measure means a long journey through a lot of cosmic gas. For some repeat, some do not. This is where the plot thickens. Early on, all FRBs seemed to be one-off events. Then, in 2016, FRB 12112 was discovered, the first repeating FRB. This was a game-changer, immediately ruling out one-time cataclysms for some sources. Since then, more repeaters have been noticed, exhibiting different patterns, some seemingly random, others with bizarre, almost clockwork like periodicity. These unique characteristics immediately sent astronomers down two very different yet equally thrilling paths. To be honest, when you hear powerful, repeating signals from deep space, the first thought for many will most likely be alien signals. And this kind of thinking may completely be valid, even exciting lines of inquiry. The idea that an advanced civilization might be using these powerful bursts as a beacon, a communication device, or even a form of propulsion isn't new in science fiction. But could it be science facts? Consider the repeating FRBs. If a natural cosmic catastrophe only happens once, then a repeating signal must come from something that can survive repeated, immense energy and radiation outbursts. Could it be a form of interstellar communication? Perhaps a galactic lighthouse guiding interstellar ships? or even the waste heat from incredibly advanced engineering projects, like a Dyson swarm harnessing the energy of a star? The scientific community always approaches such claims with rigorous skepticism, because extraordinary claims demand extraordinary evidence. The possibility undeniably may electrify public imaginations. After all, we are talking about the holy grail of astrobiology. Researchers at projects like SETI, the search for extraterrestrial intelligence, are designed to look for precisely these kinds of signals. However, the energy output required for an intelligent beacon detectable across billions of light years is truly astronomical, even for a hyper-advanced civilization. Even the signals themselves, while powerful, don't show the complex encoding or narrow bandwidth we might expect from an intentional communication. They seem to look natural. So, while the thought of an alien intelligence sending us cosmic postcards is thrilling, the scientific evidence, as of today, strongly leans towards natural sources, though extreme astrophysical phenomena. But that doesn't make the natural explanations any less intriguing. If not aliens, then what in the universe could unleash such incredible bursts of energy? The answer lies in some of the most extreme, most violent objects known to modern physics. Our prime suspects are neutron stars. These are not just dead stars. They are the superdense, collapsed cores of massive stars that have gone supernova. Imagine squeezing something more massive than our sun into a sphere, just 20 kilometers wide. Their gravity is immense, their rotation is dizzying, and their magnetic fields are beyond comprehension. But among neutron stars, there is a special breed, magnetars. These are the most magnetic objects in the known universe, with magnetic field trillions of times stronger than of the Earth. If you stood within 1,000 kilometers of a magnetar, its magnetic field would rip you apart atom by atom. Scientists now believe that starquakes on the surface of these magnetars, sudden, violent shifts in their incredibly rigid crust, can unleash immense bursts of energy, including radio waves, X-rays, and even gamma rays. These events are often called flares, and they are incredibly powerful. And then came the smoking gun. In April 2020, something truly extraordinary happened. Astronomers detected an FRB 2004-228 that originated from a magnetar within our very own Milky Way galaxy. This was a game changer. For the first time, we had a confirmed FRB source, and it was a magnetar. This single detection proved definitively that magnetars are capable of producing fast radio bursts. This does not mean all FRBs come from magnetars, especially the ones billions of light years away, which might be even more energetic. But it gives us a powerful new lead. Other leading candidates for FRB sources, especially the non-repeating ones, include colliding neutron stars, the unimaginably violent merger of two super-dense neutron stars. This event also generates gravitational waves, as detected by LIGO and Virgo, and creates heavy elements like gold. The sheer energy release could certainly power an FRB. Another is black holes devouring stars. When a star gets too close to a supermassive black hole, it can be torn apart by tidal forces, creating a spectacular burst of energy as the stellar material spirals into the black hole. Then we have the aftermath of supernovae. The collapse of a massive star into a neutron star or black hole might also trigger extreme radio bursts. The universe is a violent place, and these extreme environments are prime candidates for generating the insane energies we see in FRBs. But here is where FRBs move beyond just being a mystery to solve. They become incredibly powerful tools for our understanding of the universe itself. Think of them as cosmic lighthouses. As these powerful radio bursts travel across billions of light years, their signals are subtly altered by the matter they pass through. Dust, gas, even the diffuse, unseen plasma that fills the space between galaxies, known as the intergalactic medium. By meticulously analyzing how much the FRB signal is smeared out or delayed across different frequencies, the dispersion measure we talked about earlier, scientists can actually measure the total amount of free electrons between us and the source. Why is this so important? Because the universe has some dirty little secrets, the missing baryon problem. Standard cosmological models predict that there should be more ordinary matter protons, neutrons, electrons in the universe than we can currently account for by observing galaxies and hot gas. A significant portion of this missing normal matter is thought to reside in the vast, unseen filaments of the cosmic web, too diffuse to be easily detected. FRBs are providing the first direct evidence to locate and measure this missing matter. They are literally illuminating the unseen cosmic web, helping us fill in a crucial piece of the universe's inventory. This is like having a cosmic X-ray machine, revealing structures we could only theorize about before. New telescopes like the Canadian Hydrogen Intensity Mapping Experiment, or CHIME, are specifically designed to be FRB's hunting machines, and the future is even brighter. Projects like the Square Kilometre Array, currently under construction in Australia and South Africa, will be the most powerful radio telescope ever built, capable of detecting FRBs from even further distances and with unprecedented detail. So, while the magnetar breakthrough was huge, the mystery of fast radio bursts is far from solved. We still have so many unanswered questions. Why do some FRBs repeat while others don't? Are they fundamentally different types of objects or different phases of the same phenomena? What causes the bizarre periodicity in some repeating FRBs? Is it linked to the rotation of the source or something more complex? How exactly are these incredible energies generated? The physics of these extreme environments pushes our understanding to its limits. And perhaps most intriguing, are there truly unique FRBs out there? Perhaps from an ancient, super-advanced civilization that we simply have not detected or recognized yet? The search for extraterrestrial intelligence continues. Every new FRB detection is a data point in this cosmic detective story. Each one provides more clue, helping astronomers in building a more complete picture of the extreme universe. We are witnessing a new era of astrophysics, driven by these fleeting, powerful signals, fast radio bursts, from accidental discovery to cosmic probes illuminating the hidden universe. Whether they are the ultimate sign of cosmic violence or a faint, almost unrecognizable whisper from an advanced intelligence, one thing is certain. They are forcing us to rethink our place in the cosmos and the incredible processes that shape it. What do you think is the most intriguing aspect of fast radio bursts? Are you still holding out hope for alien contact? Or do you find the sheer power of cosmic phenomena more inspiring? Let us know your thoughts in the comments section. And if you have found this deep dive into the universe's most powerful